Hi everyone, Mrs. Gogerty is here, and we're going to continue on with our discussion about derivatives. So if you don't already have the 3.5 note sheet printed out, please go and get that, or make sure that you have your notebook ready to go. Today we're going to just really expand on something that we started with in chapter 2. So just putting it out there before we get going, in chapter 2, Mr. Rosick in video 3 or 4 went over some very common limits of trig functions that we need to have memorized. So if you don't already have a sheet of notes started with things that I need to know for calculus, I would highly recommend that you do this and go back to the 3.3 note worksheet and copy those limits down, because we're going to see those come back in this section in your problem sets. Okay, so the new part for this section though is going to be, now how do we actually take derivatives on our trig functions? So sine, cosine, tangent, secant, cosecant, cotangent, they all have derivatives. And today in our video, we are going to derive those and make sure that we're good in understanding them. At the end of this, I would highly recommend that those 6 derivatives make it onto your note sheet that is strictly things I need to have memorized for calculus. Okay, so with that, let's kind of get started here. All right, now, earlier in this chapter, you were asked to already graph a sine function and determine its derivative. So do you remember what the derivative of sine is? If not, no worries, because we're going to actually go through the limit definition and prove that the derivative of sine comes out to be, we'll fill that blank in a little bit. Okay. All right. So let's kind of start from the beginning. So if they're specifically asking us to use the limit definition of a derivative, okay, then what we are referring to now, remember there's different forms of this too, but in general, we're looking at the limit as h goes to 0 of f of x plus h minus f of x over, now technically we'd have x plus h minus x, so we know that that just cancels out to give us h on the bottom. Okay, so basically what this is leading us to is we want the limit as h approaches 0 of the sine of x plus h minus sine of x all over h. This is what we need to blow up and explore. Okay, well, the hard part of this now is that you need to remember some really critical, important things from pre-calculus, and that in order to figure out the sine of x plus h, we have to use our sum formulas for sine. Okay, now I didn't actually plug 0 in. I should have paused and plugged 0 in, and in doing that, we would have ended up basically getting something over 0, which would have been undefined, so we can't just substitute. All right, so what I'm going to look at here is taking sine of x plus h and expanding this using our sum formulas. So where we're at now, we have the limit as h approaches 0. Do you remember that lovely formula? Sine of x cosine h plus cosine x sine h. And then we'll have our minus sine x. So just to keep this rolling, the part that I'm highlighting here is the expanded form of sine of x plus h. And now this is all over h. Okay? And at this point, you might look at it and be like, okay, where the heck am I going from here? All right, well, let's try to make some stuff stand out. This term and the term over here both have sine of x, okay? So since they both have a like term, we can group those and factor. So I'm specifically, once again, looking at these 2 terms. And what I'm able to do next, okay, is I can rewrite it. I can put them next to each other, but that's kind of an extra step we don't have to have. But for those of you that you think it would help, all I'm doing is moving around my terms so that I'm specifically able to look at, let's get a different color here, these 2. Okay, now I feel like that's an optional step. You don't need to do that. But for some of us, oh, no, I just erased, hold on. For some of us, that might help a little bit to see that the next thing we have to do is factor out sine of x. And when we do that, we get cosine h minus 1, okay, plus cosine x sine h all over h. Okay, now what the heck is happening here? Okay, well, we're still playing around with trig. I feel like we're doing a trig identity from last year, okay? We're still playing around trying to maneuver this and trying to make it look like something we can work with. Now, the reason I prefaced in the very beginning of class that you might want to go back and look at that 2.3 worksheet or note sheet is that we're taking the limit right now of trig functions. So we need to remember what the limit of some of our trig functions is. So, okay, I want us to look at separating out this fraction, okay? So what's happening here is I'm going to look at this as the limit as h approaches 0 of sine of x times cosine h minus 1 all over h plus the limit as h approaches 0 of cosine x sine h all over h, okay? And we're getting closer to this now of, okay, so now what's happening? Now what can we do? All right, so I'm gonna try to highlight again, okay? This right here is a memorized limit, okay? Same with this one over here, okay? If you go back and you look at our chapter 2 notes, you're gonna see that, hey, I can take the limit, I have it memorized, as h approaches 0 of cosine of h minus 1 over h, and that has the value of 0. So right now what's happening is we'd have sine of x times 0, and then we're adding that to the cosine of x times, well, the limit of sine of h over h as h approaches 0 is 1. So what we get from all of this is cosine of x. So what just happened here? We just determined that the derivative of sine of x is cosine x. This right here is you need to memorize. This needs to be a part of a list of something you've got down for this class. Okay? So the derivative of sine is cosine. Now, we have actually seen this before a little bit when earlier in the chapter, we were asked to graph sine of x. So how about just for like, hey, memory's sake here, okay? If I asked you to graph sine, we should all be able to go and give a general sine wave, okay? And we know the highest values are 1, the lowest is -1. I'm hoping that you still feel pretty confident that you can draw out the parent function of sine without much work, okay? My question now at this point is, could you turn this into a derivative? So I'm gonna go quiet here for a moment. I want you guys to take a second, draw the derivative of the sine function, okay? All right, I'm assuming you're coming back to me. How's it going? Okay, well, did you get cosine? That's how you're gonna know, right? I'm gonna look at tangent lines. Well, at pi over 2, I'm gonna have a slope of 0. At 3 pi over 2, I'm gonna have another slope of 0. So when I'm graphing my dy dx, at pi over 2 and at 3 pi over 2, I'm gonna get an output of 0, okay? So now let's think about, well, what did we estimate the slope of the tangent line here at 0? And that's a 1. But here at pi, the tangent line, the slope, we would estimate it at -1. And when we get back to 2 pi over here, here's my tangent line, we're back to 1. And look at this. If we start graphing all of these in, here is just a visual confirmation that the derivative of sine is cosine. Okay? So dy dx of sine is cosine. Okay? Now, I'm not going to do the cosine equation for you, but now, based off of what I did in number 1, I would really encourage all of you to go and do this one on your own. Not even necessarily right now, but you can pause the video and do it, but go and try to figure this out. What does it come out to be? Now, a faster way for us to just determine it for right now is to say, okay, well, let's look at the graph of f of x. What does cosine look like? Can we estimate through a graph of what the derivative of cosine is going to be? And we have seen this before, so we should be able to do it. But okay, here's cosine, roughly, very rough sketch. Okay. And it's not the best. Forgive me a little bit here. Okay. But overall, here's our pi over 2, here's pi, 3 pi over 2, and 2 pi. Height of 1, minimum of -1, sorry, maximum of 1, minimum -1. Okay, so now if I want you to do the derivative, we should be able to look at the slopes of the tangent lines. Okay, and what do we get when we look at those slopes? So I still have my key features, pi over 2, pi, 3 pi over 2, 2 pi. And let's start with 1 up at the top. If I looked right here and drew in a tangent line, its slope is 0. Okay. Also at pi, I'm going to have a 0. And at 2 pi, slope of the tangent line is 0 again. Okay. So what's the slope of the tangent line here at pi over 2? I'm going to get a -1. And at 3 pi over 2, I'm going to estimate that at a +1. And what do we get out? What does that graph look like? Hopefully we can say negative sine of x. So here's going to be your hint. Back here at number 4, if I want to know what is the derivative of cosine, when we do all of the algebra, we should get out a negative sine of x. This should be another memorized derivative. Okay? The derivative of cosine is negative sine. All right? Okay. Make sure you do number 4 on your own. Okay? Does your algebra produce negative sine? Okay. So I actually already concluded about the derivative of sine. So d dx of cosine of x is negative sine of x. All right. So now that we have those two, since all trig functions can be turned into sine and cosine, we should be able to derive the other 4 trig functions derivatives. Okay. So our first thing is going to be to take all of these, put them in terms of sine and cosine, and if we put them in terms of sine and cosine, then we should be pretty good to go in determining our final derivatives. So let's do one together. We'll actually do a few of these together, and then you are going to try the other ones on your own, okay? So let's look at this, that I want the derivative of tangent x. Well, tangent is sine divided by cosine. Those lovely trig identities are not going away. We still need to know those from last year, okay? So now that we have this in terms of sine and cosine, we just derived the derivative of sine. We looked at the graph of the derivative of cosine, and we're looking at one function divided by the other. Any ideas what you're going to use? Think about what you've learned in the previous few videos. What rule is going to allow us to find the derivative? And if you're thinking quotient rule, You are on the right track. Okay? So as I start this off, and I'm going to make this bigger so we have some room in here. Okay? I'm going to specifically now look at sine divided by cosine. I'm not looking at it as tangent anymore. Okay? So as I start writing out this derivative, okay, there's all different ways like to memorize this low d high minus high d low, or whatever other trick that we're going to be looking at to help you memorize the rule. But overall, I'm going to have the denominator times the derivative of the numerator, okay, minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so all right, I'm going to keep going now. So I'm looking at, I have cosine x. Now I need to multiply that by the derivative of sine. Well, the derivative of sine is cosine. So the derivative of sine, I'm filling in cosine, minus sine. Now I need the derivative of cosine. And the derivative of cosine is negative sine. So derivative of cosine, I just replaced negative sine. Please make sure you put negative sine in parentheses so it doesn't look like you're subtracting sine. We are multiplying that, okay? Back to all over cosine squared. So in essence, what we've got going on the top right now, cosine x times cosine x means I have cosine squared x. Then I've got a negative sine times, well, I have a minus sine x times a negative sine x. That's going to turn into sine squared of x, right? Because you have a negative and a negative all over cosine squared. Anybody getting a little excited from pre-calc? Come on, what do we got going on? I'm going to get a little excited for us, right? Cosine squared plus sine squared. It's like the best identity ever because it ends up giving you 1 over cosine squared, right? Cosine squared plus sine squared is 1. That is our Pythagorean identity from pre-calc, okay? So in the end here, we have 1 over cosine squared. How else can we write 1 over cosine, right? What was the identity? 1 over cosine is secant. So we get secant squared. So what can I conclude from this? What can you conclude from this? The derivative of tangent of x is secant squared x. And I'm going to use yellow now. Okay. Now I'm going to tell you, you should memorize that. Okay, it's going to be so much easier in your future if you memorize it, because I think the last thing you'd want to do on a test, quiz, AP exam, right, is to derive that. Now, I know right now everything is in this open notes phase, right, but you need to have this down. So this sheet that I keep talking about that you should have right now, you should have added today that the derivative of sine is cosine. You should have added that the derivative of cosine is negative sine. You should now add that the derivative of tangent is secant squared. Okay? Please, please, please do that. All right? So I'm going to tell you that it's really similar for the next one. So here's the deal. I want you to try this on your own. Whether you do it right now or later, I need you to go and track down what is the derivative of cotangent. Now, obviously, when you read and take notes out of your book for this section, which I'm hoping everyone's going to do, you're going to see the final answer. But can you get there on your own? Okay? So for right now, I want us to do another one. Okay? So how about we try maybe number 11? Okay? So we're going to do the derivative of secant. Okay, so that means I need the derivative, or y prime, okay, of secant of x. Well, I can't just do secant right away. I need to change that into sine and cosine, or some variation. So I'm looking at that, really what I'm after is what is the derivative of 1 over cosine x. All right. This one's actually, I feel like, a little bit easier than the last one because we have a 1 in the numerator. We don't have another trig function. So we are still using our quotient rule. And the reason I'm using my quotient rule is because I have a number divided by another number. So if I'm going to start writing this out, okay, I've got the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so I just used my quotient rule, writing it all out. And let's see, what happens? In the numerator, I'll have cosine of x. What's the derivative of 0? Okay, or sorry, not the derivative of 0. What is the derivative of 1? I basically just told you the answer by accident. Okay, if we just have 1, 1's a horizontal line. So the derivative of a horizontal line, what's the slope? It's 0. Okay, so that derivative of 1 coming out to 0, that's going to make some things nicer for us. Then I'm going to have 1 times the derivative of cosine. Well, what's the derivative of cosine? Okay, the derivative of cosine is negative sine. Okay, and that will all be over cosine squared. So just to highlight that change again, the derivative of cosine x was negative sine x. So now let's see what we're left with. I've got cosine of x times 0. Well, as I said, that's pretty sweet because that just went away to 0. That's done. So actually what I've got on my numerator is sine of x divided by cosine squared of x. So let's see if we can simplify this out a little bit. This is the same thing as sine of x over cosine times 1 over cosine. That means, oops, sorry about that. That means we have tangent x times secant of x. That's a pretty big derivative. Okay, so to conclude, something that I'm going to put on my need to memorize this, I'm going to need to know it for my AP exam eventually. Tangent x times secant of x. Let's highlight that up. This should now be on my things that I need to have memorized for calculus. Okay, and better yet, we derived, where did it come from? We're using all of the skills that we have learned in this section so far, or this chapter, of like, hey, I need to know my trig identities. I need to know the quotient rule. I need to know how to take the derivative, whether it's a trig function or it's a constant, something along those lines. Okay, so I'm going to leave this as I really want you to take these other two and try these. Okay, how far can you get? Like, do you get stuck? If you get stuck, excuse me, you should really come to your teachers and ask for help on that, okay? So that we can definitely lead you through that a little bit more. All right, so other than that, I'm gonna wrap up this video with just one more question now, okay? So if we come down here to, let's say, number 12, and I'm asking you at this point to find the derivative, and we have the trig functions mixed in with it, we should be all good. So if I take a look at number 12 really quick, so if we have y equals x squared plus sine of x, remember that this means that dy dx, if we're trying to track it down, you can find the derivative of each individual piece along the way. Now this step that I'm writing out is totally optional. You do not need to do that, because if you can right away say, oh, hey, I know the derivative of x squared is 2x. And I know the derivative of sine of x, it's cosine of x. Well, now there's your answer. Y prime, or dy dx, however notation we want to use, is 2x plus cosine of x. And ladies and gentlemen, there is your crash course, if you will, on how do you find the derivative of some of our trig functions. Now, please, please, please go back and fill in, derive the 3 that I didn't do, okay? You guys have a great day, and I'll see you in our next video.